Good afternoon. My name is Kshitij Gaikwad, and this is my final Mechatronics project. I have made a mechanism that could be chosen to have an inclination as we want. This has been designed to avoid the strains that you get while using a laptop when it's kept on the desk. The angle of the screen is quite odd to look at, and that's why you have to crouch. So instead of doing that, we could just simply elevate it. The keyboard would go here so that the screen would be perpendicular to the where we want to see it, which could help us reduce the strain on the back and give us a more comfortable usage. The microcontroller I've used is Arduino Uno, and two major sensors that I've used are analog sensor LM35 for the temperature and MPU 6050, a gyroscope, accelerometer, and a temperature sensor. For this part, we have only used the accelerometer here. We can control and see the functioning of the mechanism through this screen, LED screen, which will prompt what sort of mode it's going to have. As you can see, these are the two buttons which will be chosen to manipulate the mechanism. Through one button we can use buttons to manipulate it, tilt it up or down. Through second button we can use the accelerometer by gesture to control how we want to move the inclined plane, how much inclined we want to make it. So let's go through the power. This is a 12 volt 1 ampere adapter that is powering the circuit, through which it comes to a buck converter which drops the voltage down to 7 volts, which then powers our Arduino Uno. From there we take a 5 volt ampere to power up various peripherals. The rating of output from 5 volts, the current that it could output is about 900 milliamps, which could be enough to power the three sensors that we have used, which is a very nominal current compared to the allowed 900 milliamperes. The total current through each data line would be 20 milliamperes. It should not exceed 20 milliamperes, and the buttons we have used with resistors would not let that happen. The total current will be under 200 milliamperes. So this is how it will operate. First, the analog sensor here, temperature sensor here is chosen to control the heat that is usually generated from laptops. I chose this because my laptop gets heated up a lot, and I thought this would be a very good attachment to this inclination laptop platform. So when the temperature goes below a particular value which we could set, the fan goes on, which will help cool the computer. This is the first small circuit that we have chosen. The motor are driven by a motor driver. This is the edge bridge motor driver. We use the first motor here on the mechanism for bidirectionally. It could be moved forward or backward. Let's talk a bit about the mechanism. This is a 30 ampere 12 volt motor, DC motor, which is geared, and through this gear we have attached a worm gear, which then moves this slab or whatever you call it, this small metal piece, which will in turn move the sliders along these sliding rails and move this crank, which are connected through hinges to the frame. The fabrication was done it's not very good to look at right now because there were not many options due to the pandemic and everything locked up. Not many workshops were available where I could go and make it, but it works. And so let's see it working. There are two modes in which you can operate it, as I said before. One is through the buttons, which could be operated through a switch. We can choose between what mode we want through these switches, and we get the prompts in the LCD. So button will help us choose the mode in which we want to change it. So let's do this. The prompt now says that none are selected. Let me just reset it so that we can start from the beginning. Okay, it powers up and it sets controller on, select mode, and choose the mode. It is prompting us to choose the mode, and it tells us that none of the modes are selected. When I press this first button, it says that the mode 1 has been chosen and use button to control. So we will use buttons here. Button 1 will make the incline go up. Button 2 will make the incline go down, the frame go down. Due to the rotation, the worm gear here, it acts much like the thing that we use to lift the cars. I'm lost for the words right now, but it's in a similar manner. The calculations were made accordingly to allow that. As I said, the fabrication is not that well made right now because of the limitations I had. This is the first mode. Now we turn this off and it prompts us again to choose the mode, select non-selected, and then we choose the second mode. This is the button that I have pressed, and it will tell us that okay, it has been played on a delay, a bit of delay, but okay, mode 2, use gyro to control. Now this is the gyro that the MPU 6050 that we are using to control, and as we pitch it according to our direction, as per our choice, I've made it that as soon as it reaches a 30-degree angle, that when we made a movement of 30-degree angle, it will start moving. That is the limit of our control. We can reduce it or change it. It's a very simple code. And yes, so various different precautions are taken so that there are the safety is maintained. I did not directly power 5 volt through the 5 volt input because though it is a regulated one, I did not want it to burn out my piece, my Arduino. So I have chosen to take a buck converter, which very much stabilizes your output voltage, and use the 7 volt to then power it. It also provided me with 900 milliamperes of current, which is then used to power various components. The gyro and the LCD are connected through I2C, and the LM35 is directly connected to the analog input. And yeah, and now I've also taken precautions that the buttons are not directly to reduce bouncing. There is a delay that software solution that I've used, that it does not consider a signal to be present until it's pressed for a particular amount of time. So the debouncing effect happens because of the continuous monitoring of whether the button was pressed for a particular period or not. So debouncing has been taken care of. We have, as you can see, we have used various resistors, 10K resistors. It is a pull-up resistor that we have used to act as an input, and I think that I have said enough. The mechanism, if you want to see, is like this. There's a Hindi word called jugaad, which means to accommodate with the things that you have. So it's a sort of that I have done here. The weight bearing capacity of this, I would have to confess, is not long, but it is very it can move my tablet very well. So I'll try and show that to you. Just I'll have to bring it. Please wait for a second. So here's the tablet, and we'll try to use the gyro again to control it. This is the gyro.